Last but certainly not least, Shawn from Zest. And Ginny, if you could bring up the slides. Thank you.
Hi, I'm Shawn Budde. I'm almost certainly the least technical person in this room. About 3 years ago, I partnered up with Douglas Merrill. I'm really echoey, aren't I? A little bit. I partnered up with Douglas Merrill, the former CIO of Google, to found ZestFinance. And we founded the company on the belief that by combining Douglas's experience with big data and my 25 years of lending experience at Citibank and Capital One, we could revolutionize the way that credit underwriting is done. So let me give you a quick primer on how credit underwriting has been done to date. So the task here is to figure out who is going to pay you back and who is not going to pay you back. And you always are making a trade-off between accepting more customers, which the marketing department tends to like, and accepting fewer customers of higher quality, which the credit department tends to like. In 1956, Bill Fair and Earl Isaacs started a company now known as FICO to bring statistics into the application of who is going to pay you back and who is not going to pay you back. And the technique they used was a logistic regression. When I joined this industry in 1986, logistic regression was the state of the art in big banks. You used it, you probably took about 10 pieces of information off the credit bureau and made a credit decision based on that information. So every customer who applied for a credit card had that credit card approved or declined based on a mathematical equation which incorporated only 10 pieces of information. Also in 1988, the state of the art in computing was a Macintosh SE. It had a 9-inch monochrome screen, 2 megabytes of RAM, 40 megabyte hard drive, which was the first one with a hard drive, and it cost about $4,000. 25 years later, the state of the art in credit underwriting is a segmented, scorecarded regression model. What you basically do is you take your population and you break it up into pieces, smaller, homogeneous populations. So that might be people who have been bankrupt, or people who have been delinquent recently, or people who have a high income. And within each of those populations, you build a regression model. The same good old-fashioned regression model that Fair Isaac has been using since 1956. Now, it takes you an analyst to go into the segmentation analysis. It takes about the same amount of work that it did in 1988 to go build each of the sub-models in there. So a model with 4 sub-models is going to take about 5 statisticians to build over about the same course of time it did back in 1988. To me, that's kind of like saying I've got a brand new computer for you. It costs 16 grand. It's got 8 megabytes of RAM. It's got 160 megabytes of storage. And it's got 4 9-inch monochrome monitors. So in essence, over the last 25 years, we have made no progress in credit underwriting. We are doing that now by taking the algorithms, the big data machine learning that Google uses to place AdWords, that Amazon uses to tell you what the hell to buy, and that Netflix uses to figure out that you like black comedies but not Jack Black comedies. And we're bringing that into consumer finance. So we have heard, I'll answer Matt's earlier question, big data is big hype. We have heard a lot of lenders talk about how much data they have. It's kind of like saying that I have a lot of pencils, so I must be an architect. And we believe that most of them do not have the tools to transform that data into actual insight. We're the only company that we know of in the US that is using the breadth of techniques that we're using. We use about 12 different modeling techniques. We use several dozen transformation techniques to turn raw data into useful variables. I'll list just a couple here. We use hidden Markov, we use random forest, we use Jacquard distance, but we're using support vector machines, naive Bayesian, a whole host of techniques. On average, our model is going to have about 12 different submodels using about 8 different techniques. So the challenge here is that once you have that science, you need the artistry to actually use it. I've worked with hundreds of statisticians over the years. A very small percentage of them are really good at using the tool to get the full value out of it. And so this is where I think the marriage of Google and Capital One experience really comes into play for us. So we've created some pretty interesting signals. For example, we look at where the IP address that a customer applies from. We compare that physical address to their home address and their work address. The further apart those two are, the higher risk a customer is. We look at the first half of your email. And if it looks like your name, you are lower risk than if it does not look like your name. So for me, S. Budde would indicate lower risk than Hot Rod 69 or M. Turck. And then another example is we look at data consistency across sources. We pull from as many as 10 different data sources, and we look to see if information that should be consistent is. So one signal is how many addresses have you had in the last 5 years? If one source is very different from another, that's high risk. So none of those signals is going to add a lot of value. You know, the 10 signals that are in that model in 1988 are still the most 10 important variables that you're going to have in our models. However, each of those signals adds a little bit of value. And when you combine thousands of those signals, you get a really, really good model. And we've got a really phenomenal model right now. So a year ago, we launched a state-of-the-art model, which contained about 70 raw data elements. And that represented a significant improvement over our original regression model, which would be more like a 1988 model. In December, we launched our first real big data machine learning model, which took us from using 70 data elements up to using thousands of data elements. And we saw overnight the opportunity to either double the number of applicants we approved or to lower our loss rate by nearly 50%. I've been doing this for 25 years. We get really excited about a model that gets a 5% improvement in loss rate. I've never seen anything do better than 10, but I never dreamed I'd see a model that was a 50% improvement over the prior model. At ZestFinance, we have one more iteration, we believe, that is going to deliver similar results. We have not yet parsed through all that data in a semantic fashion to find all the gold that is in there. We're going to have one more iteration that's going to give us a step change function in lowering loss rates. We believe that this technique is going to work across the industry. It will work across all consumer segments, and it will work across all lending products. And if it works anywhere near what we've achieved so far, it's worth about $20 billion a year in lower credit losses. $20 billion savings in credit losses means that consumers are going to pay less for credit, and it also means that the availability of credit will expand. That's it. Thank you.